Funding is critical. While you can do some research just by sitting thinking in your room, and that's very important. As an experimentalist, if you don't have an experiment, then there's not much point. And if you don't have any money, you don't have an experiment. So it's critical.
Actually, somewhat even more interesting is last year, D0 observed for the first time ZZ production at Tevatron and measured its cross-section. Now, this is the lowest cross-section ever measured at a Hadron Collider.
Operating costs are dominated by the cost of liquid helium, which has also gone up from 3.5 a liter to 5.40 a liter. So we've also asked for a little more money to deal with that, and ongoing. This number.
The whole of the United Kingdom's particle physics program basically stands up there and tries to justify its existence and make the case that this is what we're doing, this is why it's important, this is why we need this amount of money.
33, of course, I'm hoping that you're going to give us more. That would be to 164.
It will be make or break for some groups and for many careers as to what actually happens in this meeting. So it's kind of annoying when people sometimes talk about science and academia as though it's an ivory tower, because it sure as hell doesn't feel like it when you've got to stand up and justify your existence like this. I first saw this on stage in Westminster when one of Andy Parker's postdocs emailed it to me while I was actually presenting the thing. It was pretty exciting at the time. Of course, things got a little less exciting later. But just to point out, the vast majority of the UK's particle physics investment is going into the LHC. The UK pays something like, well, now it pays about £80 million a year to be in CERN. And we're about 15% of CERN. So it's several billion. It's cost the UK about £1 billion, and it's cost internationally 5 or 6 billion, maybe more. We will find the Higgs boson, a candidate standard model Higgs boson, or we will falsify the standard model in the electroweak symmetry breaking sector. We do have a massive coverage of low energy supersymmetric scenarios, possible extra dimensions, black holes, alternative electroweak symmetry breaking scenarios if there is no. If you really want to do stuff like understand the universe, there's no company that's going to say, okay, we'll give you this much money to understand the universe. Of course, at the higher level, we have to argue why should it be these tens of millions in particle physics? Why should you do particle physics in the first place?
People's mood has been going up and down over the last year. There was huge excitement in the build-up to 10th of September. The first start-up of the LHC, and particles circulating in the ring for the first time, which was really wonderful to see. But then after a few days running, we had an accident. So then people were a bit depressed and uncertain, and yet determined. So we'd lost the beam, but we knew we'd only just, tuned everything up and got the detector together, and so we carried on with commissioning the detector using cosmic rays. So these hit the rock above the detector and actually penetrate through the rock and go right the way through the middle of the Atlas experiment. Everyone was really pulling together to make sure that we carry on with getting the detector ready to be in the absolute best condition when the beam comes back.
Being involved in these cutting edge activities and engaging people on fundamental problems about the world around them and the universe around us is something that has unpredictable benefits. If they were predictable, the taxpayer wouldn't need to fund them. Particle physics is not an isolated activity. It's part of a human quest to find out what on earth is going on in the universe around us. If there were no particle physicists in the world and there was no one asking these big questions and trying to address them, then it would have a real negative impact on solving the practical problems in the end as well.
I give you a very simple example. For example, a very simple example, and you tell me that with what we have now we can do or not.
Discuss it usually after that she'll explain it.
No, you listen to Fauzi because I have no idea what he's going to
say. Each of us will say.
This is the parameter you're after.
This is the workshop where just 2 years ago with John we started thinking about the questions that eventually became the Eurostar paper.
Okay, since this is a really simple case, you can actually get PFT analytically. Okay, because you know that this is a Gaussian, sum of two Gaussian.
But you could do them easily. John and I were both here. So we happened to meet in the library here, and started discussing something and discovered we were both interested in it. But we didn't quite realize where it was going to go then. And it's only a couple of weeks after this workshop that we suddenly realized the potential of what we'd been discussing.
The theory should quantify this statement.
What do you mean?
You probably want to put a neutrino on here.
Oh yeah, yeah. Okay. Well, this is you get the idea.
I do, but people are connected.
That'll be okay. I can't think of anything. I mean, I can't think of anything obvious that we're going to get in trouble with. You know, like difficult questions.
No, there might well be difficult characters there, but everyone who knows anything about Higgsness is going to be in the mix. So.
Yeah.
But,
what would people be difficult about?
Right.
Oh, usually that we just haven't done it the way they do it.
Well, yeah.
Assuming we haven't missed anything completely obvious.
Yeah, a bit of just a lack of. Some people need a lot of convincing.
So how significant is it for this paper to make this presentation?
Very, yeah.
We've already got to the point that the precision with which we're measuring cosmic ray tracks is really quite close to the ideal precision. We're quite pleased with how well we've been able to align the detector. We're reclosing the detector, so it's the usual thing. At each step we have to test that nothing has got disconnected, that everything's working, and get the experiment into the final configuration. Now the anticipation's building again for starting up, and I think that people are nervous, people are excited. We're really hoping that things will go smoothly this time. We've done a very careful job and we've done all the testing, but there's always in the back of your mind, oh, what if, what if?
From leading order to next leading order, as I said, the fraction of Z plus heavy quarks can be significantly higher, as you see in this publication, when you go to...
It's very difficult to reconstruct these events, which means that if you just use the Acer MC for generating your WBB background, actually you overestimate your ability to reconstruct these events, which is so we find actually that Herwig models it better in our case.
You know how it compares to the next leading order? Is that sort of an old problem with the Tevatron? 1.5 factor or anything?
Well, we find that it's around. Yeah, it's about 2, but we also find that the signal is about 1.4. And there will be a pub note available soon for conference season, and if you're interested in more, there's loads of material in the note, basically. Thanks.
Okay, many thanks. Adam?
We're on the cutting edge of the trigger as well as the...
Yes, yes.
Yeah. Good.
Okay, yeah.
Yeah, well done, Adam. It's a question that obviously gets asked a lot. That you ask yourself a lot, actually, when you see, the world has big problems, and you think, why am I spending my whole time trying to find the origins of mass? The answer 99% of the time is it's because I find it really exciting and I want to know the answer. But every now and then you step back from that and think, that there are a lot of problems in the world about, sustainable energy. The people are sick, so you've got diseases that strike people you love, and you think, why am I not working on trying to cure diseases and things instead? It's precisely because you don't know what